guys, welcome to tutorial 3 and the delta y transformation. In this video we are going to use the delta y transformation to calculate current I1 and I2. So you can see we have two delta shapes. We have 12, 6 and 18 forming a delta shape. We have 18, 6 and 12 forming another delta shape. So you can decide to change any of them to its equivalent y. But for the purpose of this video, we are all going to change the down delta shape to the y network. Alright, so let's see how we can change it. I'm now going to draw the y inside the circuit. The y. So let's say we are changing this down here. So our y is going to look like this. We have this. Just draw your y inside our delta. So let's get the value of this y network. So let's call this one, let's say RA. This is RB. And this is RC. So what is RA giving us? RA, now you all know how to use the formula. Let's go straight forward. RA is between two delta values, 18 and 6. So we are going to multiply those two values. So 18 by 6 divided by the summation of the delta values. So 18 plus 6 plus 12, which gives us, so we have 18 by 6 over 18 plus 6 plus 12, which gives us 3 ohms. So we find the next y, let's say RB. So RB is RB is between 6 and 12. So we have 6 by 12 over 18 plus 6 plus 12, which gives us, so 6 by 12. The denominator is the same for this transformation. So 6 by 12, which gives us 2 ohms. So the last value left is the RC. So RC is giving us is between these two. So 18 and 12 divided by the summation, which is 18 plus 6 plus 12. And on our calculator we have 6 ohms. So now let's draw the circuit and replace the delta shape here by the y. So we have this 12 and 6, 18 are still there. They were not transformed. Good. Now we are replacing the delta by this y. So one is connected at this point. This one is connected here. So we have the y like this. Then we have our branch RC, resistor RC here. So we can draw our circuits like that. So let's have our values there. We have 12, 18. Now since 18 and 12 are not going to appear in our new circuit, but then we have RA, which is 3, RB, which is 2, and RC, which is 6. Now let's see how we can get our total resistance. So we've transformed. We can now apply our network reduction here and get our total resistance. Good. So our total current is being produced here. Let's see what happens. On this branch, it comes down. When it gets here, it makes two branches. So current will split. Some will pass here, some will pass here. So if it splits, means the resistors on those two branches are in parallel. But when I look on this branch, I have this 12 in series of the 3. So I can't just do 12 and 18 in parallel, whilst I have another resistor on that same branch with the 12. So I need to do this 12 and 3 in series first. Get its equivalent here. This 18 is also in series with the 2. I have to get its equivalent. Now the current split between this and that. So those two are in parallel. Current is not splitting in the 6. Don't come and worry the 6. Just focus on where the current was splitted. So I have an equivalent here, which I know, let's say RA is 12 plus 3, which is 15 ohms. I have another equivalent here, let's say RB, and that one is 18 plus 2, which is 20 ohms. So let's draw our circuit and get our values. But then we can do straightforward here. We know that the RA we have here will be parallel with what? The RB. So we can just calculate and can save some of the space. So RA parallel with what? RB. Let's call it RC. So RC is this and that in parallel, which is 15 by 20 over what? 15 plus what? 20. And that one is giving us 15 by 20 over 15 plus 20. Then we have 60 on 7. 60 on what? 7 ohms. So don't forget, we've now get an equivalent for all this portion. Series, parallel. And we get 60 on what? 7. So let's draw the final circuit. Let's draw the final circuit. So we have all this portion giving us one value here. And that value is connected to what? This junction here, which is somewhere here. And then we have the source connected. So let me bring it here. Good. So we have the 60 on 7. And we have what? Our source ohms. And we have what? Our source, which is 10 volts. So from here, we can go on ahead and calculate what? The total resistance. So what is the total resistance? Total resistance RT is what? 60 on 7 plus 6. So RT is giving us 60 on 7 plus 6, which is 102 on 7 ohm. That's the total resistance. So what is the total current? IT from Ohm's law, VT, that is the 10 over what? RT. So 10 divided by the resistance is giving us the total current to be 0.686. In fraction, I have 35 on 51 amperes. So that's the total current flowing IT. So what we are going to do is to go back, the network reduction approach. We are going back. We know the current in this one. We know the current in that one. So let's go back. Now, we are just going to focus on which resistors? The 18 and the 6. That's the resistors we need their currents. But don't forget, those resistors have been transformed. So they are not appearing in this diagram. They have been transformed. So how then do we get their current? That's the important question. How do we get their current when they are not appearing in this diagram? But let's see. The current in this one we know. When I go back small, where from this 60 on 7? This 60 on 7 is from where? The parallel combination of what? The 15 here and what? The 20 here. I believe you remember the 15 here and the 20 here. They were in parallel to give us what? The 60 on 7. So for us to get current in any of them, I have to apply the current divider rule. So let's say we want to calculate the current in the 15 ohms here. That's the RA. I want to get its current. So let's say current in what? 15 ohms. It will be what? The opposite, which is what? The RB 20 here. The opposite, which is 20 over what? Sum of those two, 15 plus what? The 20 times the current they are sharing, which is the total current. 35 on what? 51. What do we have? We have 20 on 15 plus 20 multiplied by what? 35 on 51. And we have 20 on 51 amperes. So the current flowing through what? The 15 here is 20 on 51 amperes. Good. What's the current flowing? We can as well find the current flowing in the 20 here by subtracting this one from their total current. So current in their 20 ohms is what? The total current, 35 on 51 minus 20 on what? 51. And that is giving us 35 on what? 51. That's giving us 5 on what? 17 what? Amperes. So we know the current flowing through the 20 ohms resistor. That's the 20 ohms here. So let's ask ourselves, this source is this source here. We have what? Its current. But see something. The 15 here, right? The current flowing through that 15 is the same as what? The current flowing through the 12 and the current flowing through what? The 3. We are going back. The current in the 15 we have, the 12 and the 3 were in series. So current in the 12 is the same as what? 20 on 51. Current in the 3 is the same as what? 20 on 51. Alright, good. When I come to this 20 here too, current in the 20 is the same as current in the 18 and the same as current in what? The 12, because they were in series to give us what? The 20. Good. Let's move back to the circuit. When I come back to the next circuit, which is the final circuit, if you see that I've transformed this 18, when I'm comparing it here, you realize that this 18 here, the 18 that I have transformed, you realize it is appearing somewhere here. Assuming we have our delta, the 18 is where? Somewhere here. This 18 is here. That's somewhere here. This is also where? This is somewhere here. This is here. This 18 is here. This 12 is where? This 12 is also somewhere here. This 12. So they are not in our diagram here because we've transformed them. But for us to get the current or voltage for this 18, it is going to depend on what? The Y values we have. The Y values we have. Let's look at something here. You will see that this 18, this RA, and this RC, it is forming a loop. Let's do some analysis here. The 18 here, the RA here, and what? The RC. They form a loop like this. So let's say this is RC, this is RA, this is what? 18. Let's say 18 ohms. This is what? The RA, and this is what? The RC. It forms a loop. And we know that from KVL, Kirchhoff's voltage law, the algebraic sum of voltages in a loop is equal to what? 0. So let's apply the concept of Kirchhoff's voltage law here and see something. Let's sum the voltages in that loop, equate it to 0, and see what is happening. But remember, voltages have what? Polarities. So for this one, let's say there is a current moving in what? RA. Okay. And there is another current moving downwards through what? RC. This current, when it flows through RA, there will be a voltage. So let me call that voltage, let's say VA. We are just doing some analysis. When this current also flows through RC, there will be a voltage. Let's call it what? VC. And let's say when this current I1 flows through 18, there will be a voltage. Let's call it V18. Alright, we are going to do this analysis and see how we can get the voltage across what? The 18 ohms. So let's see. In KVL2, let's take a loop. We are going to sum voltages. But voltages have polarity. What will be the polarity of this VA? Where will the plus be? Where will the minus be? You can see that the current was moving down. So the plus will be a plus, minus. This one to the current is moving down. Plus, minus. This I1 is also moving down. Plus what? Minus. So we have plus, minus for this VA. Plus, minus for this VC. Plus, minus for what? The V18. So we are summing the voltages. So let's start from V18. V18, we are moving in what? Clockwise direction. We will enter the negative voltage and leave the positive. So for now, we've not done KVL, but let's see. Let's stick to this rule. This plus and minus, where we are leaving, the terminal we are leaving is going to be what? The voltage for that resistor. So for this 18 ohms resistor, I have the voltage V8, which is plus minus. I'm going clockwise, so I'll enter the negative and leave where? The positive terminal. So let's say the voltage here is positive. So I have positive what? V18. When I come to this one, the plus is here, the minus. I'm going clockwise. I'll enter positive and leave negative. So the voltage for the RA is negative what? VA. And I come to VC. I have plus and minus. I'm moving clockwise. I'll enter positive, leave negative. So minus what? VC. And that one is what? 0. KVL. Our algebraic sum of voltages is equal to 0. So how will we get V18? It means V18 is equal to what? VA plus VC. Have you seen the expression? What it means is, if I want to get the voltage for this 18, which has been transformed, it will depend on what? The voltage of this RA here, that's the 3, and what? The voltage of this RC, which is the source. The summation of these two voltages is going to give me what? The voltage for this 18 ohms, which is not in the diagram. So for us to get its current, we can use this idea, get the voltage, then from Ohm's law, I is what? V over R. Then we divide that voltage by the 18 before we get the current. It's a very simple step. Just take time, go through the video and see how we do our analysis. So the voltage for 18 is going to be voltage for the RA plus voltage for what? The RC. The same thing will happen to the 12 ohms here because of things we won't do it. But for the 12 ohms, if I want to get its voltage, it's also going to depend on what? RB and RC. Why? Because it is forming a loop with these two. So voltage for 12 will be voltage for RB plus voltage for RC. But then let's look at this one, the source here, which has also been transformed. Let's look at this source here. So let me clean for the 18 that we've done and let's analyze for the source. Let's see something. Let's take this loop here. This loop. The source, the 3 and 2. The source, RA and RB are also forming a loop, right? So like we did for the other one, I have this. This forming a loop. This is RE. This is RB. And this is what the source. Let's say there is a voltage here. Let's say VA, VB. Let's call this one V source. What's the current direction? I2 is moving this way. So it means the voltage for the V source is plus minus. This one, its current is moving down, so we still have what? Plus minus. This one is also the current. Let's say there's a current here moving down like this. Alright, because this I2 will come, meet up with a current here, then the current will continue. So there's a current through RB. So since it is moving down like this, there will be plus and minus for the voltage, plus minus. So let's apply the KVL here and see. So when we are moving in a clockwise what? Direction. Let's start from this one. I'll enter negative and leave positive. So positive what? VA. I'll come to this one. I'll enter positive and leave where? The negative. So negative versus. For this one, I'll enter positive and leave where? Negative. So I have negative what? VB is equal to 0. KVL. So let's see how we can get what? Vs. So Vs is what? VA minus VB. It means for us to get voltage for this 6 ohms, which has been transformed, is going to be what? The voltage for what? RA minus the voltage for RB. Alright, the voltage for RA minus the voltage for RB will give us what? The voltage for the source. So we can get that voltage, then later divide that voltage by source and get the current. 18 is what? The voltage of RA plus the voltage of RC. If you are interested in 12, it will be the voltage of RB plus the voltage of RC. But if you are interested in the source, it is the voltage of RA minus the voltage of what? RB. So we are now going to focus on these two. 18 ohms. I believe it's understandable. Good. So let's solve for what? The voltage. We now know what we are after, so we'll move on. We need the voltage for what? RA and voltage for what? RC. So voltage for what? RA is what? The current through what? RA. RA is the 3, don't forget. RA is the 15, which is having the same current as what? The 3 here. So we are interested in this 3, its voltage. And this is its voltage. So voltage for this one is the current through this one. And what's the current through this one? The current through the 15, we know it is what? 20 and 51. So the voltage will be what? The current times what? The resistor. V is equal to IR. So the voltage is what? 20 on 51 by 3. And we have 20 on 17 volts. So we have voltage for this one. Let's calculate what voltage for this is. So voltage for 6 ohms. What's that? 6 ohms is what? RC. So RC it is 6. You can call it what? RC or SIS. So voltage for this is, what's the current for this is? The current for this is the same as what? This is here, the same as the total current. We have its current as the total current. So its voltage is the total current, the 35 on what? 51 by the resistor what? SIS. So 35 on 51 by SIS, which gives us 70 on what? 17 volts. So the voltage across this is 70 on 17 volts. Now let's get the voltage for what? This RB, because for me to work on this I'll need RA, RB. I have for RA, so let's get the voltage for RB. So voltage for RB, we need the current through RB, which is what? The RB is the 2, and it was in series with 18 to give us 20, and we know the current for the 20. You will just take your time. Current for 20 is this, which means the current through the 2 is also what? That. So each voltage is what? 5 on 17 by the resistor 2, and we have what? 10 on 17 volts. So we have the voltage RA, voltage for RC, voltage for what? RB. We can now calculate what? Voltage for 18 from the analysis we did. The voltage for RA plus the voltage for RC. Then calculate for what? Voltage for the SIS, which is what? The voltage for RA minus the voltage for RB. Are you okay? So I would love to clean this small portion here, but don't forget what we are doing. We are just going to sum the voltage of RA and RC to get voltage for the 18. Then subtract the voltage of RB minus from the voltage of RA to get what? The voltage for the 6 ohms. So let's clean. Get your diagram on your paper, then I can clean. Good. So voltage for the 18, that's 18 is what? Voltage for the RA plus voltage for what? The 6 ohms. And voltage for RA, what did we get? We got 20 on 17 plus voltage for the 6. We had 70 on what? 17. And what do we have for this? We have 20 on 17 plus 70 on what? 17. And that's giving us 90 on what? 17 volts. That's the voltage for the 18. But the question is asking for what? The current. And the current, the question gave you to what? I1. Look at the question again. It is I1, the current through the 18. So current through 18 ohms, which is what? I1, is equal to V of the 18 divided by what? 18. And that is 90 on 17 divided by 18. And we have a current of what? 5 on 17 amperes flowing through what? The 18 ohms resistor. Now it's left with I1, which is the current through the 6 ohms. And we know the voltage for the 6 is what? We've already deduced that the voltage for what? The 6 ohms. I mean the 6 ohms there is equal to what? The voltage of what? RA minus the voltage of what? RB. And we have it to be, what is RA? RA is 20 on 17 minus RB is what? 10 on 17. What do we have? We have 10 on 17, right? So we have 10 on 17 volts. That's the voltage across the 6 ohms. We need what? Its current. So very simple, we need its current. So current in the 6, current in the 6 ohms, which is the same as I2 from the question, is giving us voltage for the 6 over the 6, which is 10 on 17 divided by 6, and that one is giving us 5 on 51 amperes. So in this diagram, we've managed to get the current we are asked to calculate. That is I1, which is 5 on 17 amperes, and what? I2, which is 5 on 51 amperes. So we are done with our question. I would love everyone to pause the video, go back again and check each and every step. Thank you very much for watching this tutorial.